Hello, everyone. My name is Darwin. Wanted to take you through a couple things that we've done with the GitLab embedded workshop and demo environment. We've added a couple exciting capabilities. Before I drop into that, I want to talk a little bit about everything in the loop and why this is a really important aspect of doing embedded development. When we think about hardware in the loop, we think about bringing our hardware into our development process so that as we iterate and improve our code, we can have the hardware in that loop. I'm going to talk a little bit about hardware in the CI loop, which is a little bit different than simply getting hardware into our development loop. In the realm of embedded development, we have a developer working on their code, and their code very quickly feeds into the bottleneck of real hardware. This might be building on real hardware, definitely testing on real hardware at the very end on the hardware that's going to be in use in our environment. This is a challenge for embedded development. It's the source of a lot of tethering of development activities to an individual workstation. It's been the source of a lot of the resistance of the ability to automate this. Now, we all know that this results in a slow feedback cycle. Here we're showing some embedded boards that are very inexpensive, but that end assembly could be very expensive in tens of thousands or even millions of dollars when trying to test on the very final hardware. AI is coming. And in the code gen area, it only threatens to make this area worse. So as we're able to work more quickly in coding and we're able to generate potentially more code that needs review and needs testing, then this bottleneck becomes even a greater challenge. AI does have a lot to offer in the embedded world. It has the ability to offer some scenarios for modernization, say moving to Rust. Also, it attracts younger coders into the discipline of embedded. Let's talk a little bit about how getting into the CI loop can open up some of these bottlenecks. One of the steps that's frequent and a lot of organizations may have already done is using cloud scalable ARM CPUs. So if ARM is your target architecture, then you have a lot of options in terms of cloud CPUs where you can do your build activities. Another thing that is increasingly popular is simulated hardware. Frequently, this has been done in the past by third parties, creating simulated hardware setups or simulated real-time OS setups. But now a lot of organizations who build this hardware are providing virtualization along with the hardware. So they're understanding how the need for development activities benefits from this. And so frequently we're seeing simulated hardware be provided as a part of a hardware platform or developer tooling for that hardware platform. So this first one is frequently referred to as software in the loop. We have processor in the loop, which is the idea of taking a lesser piece of hardware and doing a certain amount of test coverage with that. So an example would be if you have a $1 million rig for the final testing, potentially boards for $500 to $800 could do a huge portion of the test coverage. And in that case, you could buy more of them, pool them, and share them, which would allow you to then essentially offset the cost of that larger hardware and improve the productivity of everyone who's working. When we have the large rigs at the end of the tunnel, so to speak, there's two real challenges to cost. One is a lot of times they're manually scheduled and folks are waiting around for them to be available. And so that's a productivity loss against their total compensation. But then you also have the issue of how many of these units to acquire. If they have low utilization, like you're only using them 40 hours out of a week or even 60 hours out of a week across some time zones, then that's a lot less than the full amount of hours there are in a week in a 24/7 setup. Environments as code is the capability to set up, update, and tear down environments with code that's coded into your project. If this environment as code capability is lifecycle managed, this can be even more valuable because individuals who are familiar with the complexities of setting up an environment can build that code and everyone else can share and use it. And that code can automatically build an environment when a branch is created, automatically update it when the branch is pushed to, and automatically delete it when the environment is no longer needed when the branch is deleted. This can be a massive help because in development, environments can turn into sprawl, which can cost a lot. I'm familiar with one organization where they had a 10x spend on development environments compared to the environments supporting production. Notice that our real hardware here at steps 3 and 5 are enabled by something that I call Device Cloud, which is a community component in GitLab. So when we get all of this hardware capability in the loop, we have a much faster feedback cycle because things move quickly, automated. We can have much better utilization of the end device. But sometimes when embedded organizations approach this, they're not as aware of the high value of what's called failing fast. So anytime we can fail at a previous stage within this particular cycle here, we cause the individual to be more productive more quickly. They don't have to wait for potentially a queue for that final device. They find out simple errors like, say, a math error at a much earlier stage. And so fail fast also increases the productivity of this entire pipeline. So if you're thinking of looking into this, keep in mind that it's not just that end device that you want to think about. You want to think about all the ways to speed this up and make it more cost efficient. Now, this feedback comes back to the developer. Then frequently you have to go look through a lot of very manual artifacts or job logs. However, when we take this feedback and put it into a much more shareable format, in GitLab, this is the merge request, we can start sharing expertise, workflow, governance, and many other things. This purple box reflects the people and process part of DevOps. So on the bottom, we are really focused here on technology and how it can add and enhance the development process. But for us to bring DevOps to embedded, the people and the process parts also need to benefit from the entire development workflow enhancements. So one of the things we benefit from is shared human expertise, discussing the actual software solution, understanding when something can be done better, or getting the expertise of others, or ensuring that only good code moves forward, or helping junior folks learn the area and learn the code base better. We also have shared workflow, though. So the bottom half of this slide represents full machine-based automation. And we want to take everything to machine-based automation that we can. But most likely, there's going to be some human workflow involved, especially if you're under compliance or other kinds of regulations. That workflow can be either completely unaccommodated, in which case it becomes sort of an out-of-band, out-of-tool, out-of-context experience, or you can have a very rich workflow capability, and then the workflows can be encoded into the system. Shared governance is another aspect that once we have our workflow and our code and all kinds of automated testing results back, we can start to apply shared governance policies so that we can be sure that things like attesting that the pipeline didn't have any bad actors in it, or ensuring that there is no new vulnerabilities entering code. All of this can be done with shared governance once we have this information. Shared AI expertise, or the ability to use AI. If you look across the entire ecosystem, you'll notice that in the areas where you'd normally collaborate with people, that's where AI is frequently exposed. And this is also a capability that you gain by moving into this world of hardware in the CI loop. Shared software build and test expertise, or I sometimes shorthand it to shared software manufacturing expertise. Basically, the idea of building a software solution is its own level of expertise. So when you're building for a certain board or for a certain embedded application, but then software manufacturing becomes so complex and nuanced that it's an expertise into itself. If you think about physical products, some engineers decide how to make a physical product, and then it's actually production engineers that figure out how to manufacture that product the best. So these are distinct expertises even in software, and we can share that expertise if we're able to create shared artifacts within the automation system. And then finally, shared visibility. And this is increasingly important, ensuring that software is secure, that it's meeting compliance requirements, and that we're generating value through our entire development process and that we're focusing on value. So all of this sharing capability is really contingent on or lit on fire by ensuring that we get hardware into the CI loop. After we can see what can be done with this with shared development, I want to label the right side and kind of call it as it is. Embedded development started as an isolated activity, frequently simply because we needed to attach hardware to the workstation. And that simple requirement caused us to have to be isolated to a certain degree. However, now that we've got a lot of enabling technologies, a lot of organizations aren't realizing that that was the original reason. And so the habit of isolated development persists. I would like to submit to you, though, that when we move to the full rest of the slide here, what we inherit is the capability to not only take advantage of shared technology and shared automation, but also shared people and shared process capabilities. And this is where we can really start to innovate at the business level. Let's take a quick look visually at what we're going to look at in the actual pipelines here. This is the pipeline that shows hardware in the CI loop. The gold box call out here is the on-premise device cloud component for actual hardware in the loop. So you create a little cloud of devices that are allocated by pipelines, used and deallocated. That's not new. We've had that out for a while, but this will be demoed. In the purple, a Walkwe emulation software in the loop CI component. Walkwe does emulation of the Raspberry Pi Pico W, which is the microcontroller that we use in these demos in lab. And this allows us to run tests on that platform. So we're able to deploy our firmware, the actual code that we build in the pipeline, and run some automated tests on it. Great capability, becoming more and more common across a lot of frameworks. The green call out here is GitLab's environments as code capability. And this has the unique attributes of being lifecycle managed, which means it automatically deploys, automatically updates whenever the pipeline is pushed to, and automatically is destroyed whenever a merge request is merged. It does a lot more than just merge requests as well, and that's handled in a different video. One of the cool capabilities here is the ability to do human in the loop testing. And human in the loop testing usually involves a user interface of some type. And we show that with this Walkwe capability. There is, however, another excellent use for this. If you have a complex setup or something that takes quite a while to deploy, let's say you have 3 virtual ECUs that you wire together and want to run tests of firmware updates that go across all 3 devices. If you had a situation where it takes 2.5 hours to deploy that, but only 15 minutes to update it, that's another great use case for virtual environments. Within GitLab, it's used for all dynamic security testing. So you can then run, if you say have API endpoints on these devices, you can run tests against them and bring those test results back into the merge request. GitLab's environments as code capability can come in very handy for both interactive as well as pipeline persisted environment setups. So that's just a couple of the capabilities we'll be taking a look at in just a minute. All right, we're here in our project. And as I mentioned, most of these shared capabilities during the development process come up through the merge request. So we'll take a look at a merge request here. And I'm going to dig into the pipeline, and then we'll come back to the merge request to talk about a few of the things that feed into here that are really helpful. So we'll dig into the last pipeline that was run. And I just wanted to highlight that we mentioned earlier about the hardware in the loop pipeline. So I actually have a device cloud of 3 Raspberry Pi Picos hooked up to what we call runner gateways, which are another board that's capable of running GitLab Runner. Could be a full machine as well if it needed to be. But it ran these 3 items, and one of those was this child pipeline that actually runs on the hardware. And so that's what we're seeing visualized here. If we drop back, let's first look at this software in the loop testing. And when we dig in here, we can see that the Walkwe CLI ran. And when it ran a test scenario called blink test. And so we can see here that it started simulation and then monitored the serial output and was able to verify that it's getting LED on, LED off. So that's kind of your standard software in the loop in CI. And then this environment was deployed here. And this job has not run, but it can optionally be destroyed. We could destroy it manually if we want to reset it and make it clean again. Or when we merge this merge request, it'll be destroyed automatically. So what this particular job did was it created a new environment under environments. And when we expand this, we can see what was deployed to this environment most recently. We can also see who deployed it, and we can open the environment. And so when I open this environment, my exact code is here. And I'm going to hit the play button here to see my code actually run and see whether we see it simply blinks the LED. And if we were to change the value that the LED blinking happens at, then we came through, the new value would be here, and we could observe the new behavior. So that's the basic concept of a graphical or human in the loop environment. And we could be using the same capability to do something automatically similar to the CI step that we saw. So we'll go back to our pipeline. And a variety of other things are going on here, but one that I want to draw attention to is that we are using Code Sonar to scan the code, which is a well-known embedded C scanner that has very deep path analysis. If we go into our merge request level, back one level, we can see here that there are findings that come from the scanner. When we click into these, we can see more details. We can go right into the Code Sonar console here to get really deep details if we need it. But one other thing I want to show you is, in this case, it's saying there's no new potential vulnerabilities. So that means that the coding I've done in this merge request has not added vulnerabilities. So these scans are for code you've changed. So I'm going to go to a different merge request that was earlier in the process, where it perceives that I did add those vulnerabilities. And so I added some new code, and these new vulnerabilities became visible. So we can see we have some high findings here. And I mentioned briefly in the slides that we have this capability to have policies as code or governance, shared governance. And if we look up here, we have this new high findings merge approval group. We now need to get a merge approval from someone in this group. Now, for demo purposes, I enable the approve button for myself, but the normal way that this would be done is that the developer who is needing the approval cannot press approve for this particular finding. So this would generally be a security group or something of that sort. So that's just closing the loop on how, once we get all of this automated data back into a place where humans can share their process as well as their capability to innovate on the code, we can have advanced things like shared governance and shared policies in play. So that's everything I wanted to show you. We're going to be demonstrating some of these capabilities at Embedded World in Austin on October 8th through 10th. I have a session which is running on October 10th, and it has been changed since it was originally announced. So it's moved up by a half an hour, but be sure to check the schedule to find it. And then we also have a GitLab booth 2059. So if you want to see any of this demoed or chat with us about any of it, please feel free to look us up at Embedded World in Austin, right around the corner. Thank you.